Hi guys, hopefully you've had a look at these two YouTube videos, which should hopefully have given you some idea of what's going on the sheet. Just to take you through it though, we've got properties of metals, so a variety of things. These good conductors. Now, this is true, they are good conductors, but if we wanted to make it 2 points, which would be 2 separate marking points in the exam, then we would want to say that it was of heat, and then good conductors of electricity. Okay, they have high melting points as a general rule. This means that they're normally solid at room temperature. They are malleable, which means that they can be bent and shaped. If you imagine taking a piece of metal and taking it and bending it, you know that it will bend and change shape rather than just breaking. So that's what it being malleable means. Okay. They are also ductile, which basically means that they can be stretched out into a wire, and they have a property known as being sonorous. S-O-N-O-R-O-U-S, and that means that when you hit them, they ring. So if you imagine a bell, we generally make bells out of metals because when you hit them, they ring. Okay. Non-metals, they're poor conductors. Of both heat and generally poor conductors of electricity. They generally have low melting points. They are generally brittle. There is another property of metals that we normally have, which is that they are shiny, and non-metals are dull. Generally, they're not shiny. So, where on the periodic table can the metals be found? Well, on the left. If you remember, we've got our periodic table that looks like this, with hydrogen up here somewhere. It actually sort of steps down here, and all of this section are metals, and the non-metals are over there. Okay, so in terms of their electronic structure, why are metals found here? They have a less than half full outer shell, generally. And this means that they're going to lose electrons. Okay, so draw the electron configurations for sodium, magnesium, and aluminium. We've got sodium has 11 because its mass number, its atomic number is 11, which means that it's got 11 protons, which means that it's got 11 electrons. So 2 in the first shell, 8 in the second, 1 in the outer shell. Magnesium has a proton number of 12, so that means it's got 12 protons, which means that it's got 12 electrons. So we're 2, 8, and then 2, and then aluminium is atomic number is 13, it's in group 3. So it has 13 protons, so it has 13 electrons. So a 2, 8, 3. Now, when these react and form ions, they're going to lose all of the electrons in their outer shell. Okay, they're not allowed to only lose some of the electrons in their outer shell when they're reacting. They're going to lose all of them. So sodium is going to lose 1, magnesium is going to lose 2, aluminium is going to lose 3. Okay, that means that sodium now only has 10 electrons because we had 11, so we've lost 1, so that means we're down to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. And the sodium ion has 1 less negative electron than positive protons in its nucleus, so it has a plus 1 charge, because we're dealing with now plus 11 from the protons, minus 10 from the electrons, and that gives plus 1 overall. So we're plus 1, which we can write as plus 1. We just write as a plus, because as chemists. We don't like to not write things if we don't have to. Magnesium, we've lost 2, so we're down to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And magnesium ion has 2 less negative electrons than positive protons in its nucleus, so it has a plus 2 charge. It's a positive charge. And if we do this bit again, so we've got protons gives us plus 12 charge, our electrons, and they give us minus 10. So plus 12 take away 10 is plus 2. And we need to put the positive sign and the 2. We need to know the magnitude of this charge, the size of the charge. Aluminium then, lost 3, so we're down to 10 from the 13 that we had. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And aluminium has 3 less negative electrons than positive protons in its nucleus, so it has a plus 3 charge. If we do that again, it had an atomic number of 13, so it's still got 13 protons. We've now only got 10 electrons, so 13 and minus 10. So if we do plus 13 take away 10, we get plus 3, and we need to write it as plus 3. You can write it as either plus 3 or 3 plus. They'll give you marks for both. Okay. If we've had a little look of this video, where do you find the noble gases in the periodic table? It's the right hand column, which is group 8 or 0. So 0 on yours. Are the noble gases reactive or unreactive? They are unreactive. And the reason that they are unreactive is because they have a full outer shell. So don't need to gain or lose electrons. Yeah, because what they're doing here is they're trying to become the electron configuration of a noble gas, and that's in fact neon in this case. So neon is that. But you'll notice that these are different because we've got these brackets around them, and we've got a positive charge indicating that it's not actually neon, but it is sodium where it's lost an electron. Hope that helps.